Okay, so this is page 2 of the final exam review, starting with question number 13. It says, how many grams of oxygen, you can write that down, how many grams of oxygen are produced when 11.5 grams of NO2 are also formed? So grams to grams, this is going to be my longest type of problem here for stoichiometry. So I know that what I'm given goes in the first box, 11.5 grams of NO2. The units that I no longer need to cancel, so grams of NO2. The only thing I can change grams into is moles of the same formula, NO2. Now I need to get rid of moles of NO2, so that goes on the bottom of the next box. Now here is where I need to change NO2 to just O2. I have to do that in moles. These have to stay the same when my formula changes. But I want grams of O2, which means I will need one last step where I convert moles of O2 into grams of O2. And I fill in all these numbers. Grams is always the molar mass. So you find the mass of each of these elements on the periodic table, add them together, and you get 46.01. Molar mass is always equal to 1 mole. Moles to moles comes from my balanced equation, so I find NO2, the coefficient is 4. I find O2, the coefficient, there isn't one, so that's 1. Grams of O2, that mass is 32 grams. Molar mass is always 1 mole. So a lot of dividing and multiplying, 11.5 divided by 46.01 divided by 4, because it's on the bottom, times 32 because it's on the top, and it gives us 1.999, or that's about 2 grams of O2. Okay, number 14 says, what is the maximum amount of water in grams, so I'm looking for grams of water, that are produced when 1.5 grams of NH3 reacts with 1.85 grams of O2 according to the given equation. What is the limiting reactant? Anytime you see this limiting reactant, or you're given 2 numbers here, you know you're going to need to set up 2 separate dimensional analysis problems. One for the first given, 1.5 grams of NH3, and the other for 1.85 grams of O2. We need to change them both into grams of H2O. So, grams cancel, and I change that to moles. Moles cancels, and I'm going to change that into moles of H2O. And then the last step is changing moles of H2O into grams of H2O. Same thing down here, except I start with grams of O2, change to moles of O2, get rid of moles of O2. This is where my problem becomes the same. Moles of H2O, get rid of moles of H2O, and grams of H2O. So, grams is always molar mass. This is 17.034. Molar mass is always 1 mole. Moles to moles comes from my balanced equation. The coefficients, the molar mass of water, 18.016. Molar mass is always 1 mole. Same thing down here. 32 grams is 1 mole. That comes from the periodic table. Moles to moles comes from my balanced equation, 5, 6. And this part is exactly the same as the one right above it. I do all this math, divided by 17.034 times 6, divided by 4, times 18.016, gives me 2.37 grams H2O. And then the second one, 1.85, divided by 32, times 6, divided by 5, times 18.016, gives me 1.24, or 5 if I round, Okay, so what are my actual answers? It says, what is the maximum amount of water that is produced? Well, my smaller answer is the one that I actually produce, so this is not my answer. This answer down here is. And then the second question, what is the limiting reactant? The limiting reactant is the compound that gave me the smaller answer. So this right here is the limiting reactant. And so that's why we have these answers here. Okay, number 15. Says if 3.2 grams of K3PO4 reacted with excess, remember anytime you see excess, cross that out, but only 4.1 grams of KNO3 are actually produced in the laboratory experiment, what is the percent yield? Here's what you need to know. Percent yield is equal to actual divided by theoretical times 100. So actual is given to us in this problem. If we read, it says only 4.1 grams are actually produced. So 4.1 grams goes at the top. Now here's a mistake a lot of people make. They put the 3.2 on the bottom. That's not true because these are not the same formula. So we have to first do some dimensional analysis where we convert 3.2 grams of K3PO4 into grams of KNO3, just like this answer is. So we get rid of grams K3PO4, convert that into moles, get rid of moles, convert that into moles of my other formula, and then last I can change that into grams. So grams, this comes from the periodic table. (212.27). Moles to moles comes from my equation, so K3PO4 is a 2, KNO3 is a 6. This also comes from the periodic table. This is 101.11. So you do this math, 3.2 divided by 212.27 times 6 divided by 2 times 101.11 gives us 4.57 grams. That number is what we plug in here. That's not our final answer. So now 4.1 divided by that answer times 100 is where we get 89.7%. Okay, number 16. Finally, not too much math. It says Rob calculated that he could produce 25.1 grams of water. So this is like what you just did in the last step where we had to change 3.2 grams into KNO3. It already did that for us. However, in the lab, he was only able to actually produce 22.6 grams. What is Rob's percent yield? Same type of problem, a little less work. Percent yield equals actual divided by theoretical times 100. Our actual, if we read carefully, is 22.6. Our theoretically calculated amount is 25.1 times 100 is how we get 90%. Number 17. It says, what is 70 degrees Celsius expressed in Kelvin units? So what you need to know is that anytime you have Celsius, you must add 273. That's how you'll get Kelvin, and that's how we get 343. If you're given Kelvin, you would have to subtract, and then that would give you Celsius. So know that in both ways. Number 18. Says the graph represents the state, changes of state for an unknown substance. What is the freezing point of the substance? So if we look at this graph, this first line represents a solid. The second diagonal line represents a liquid, and the last diagonal line represents a gas. So we know that freezing means when a liquid turns into a solid. So when a liquid right here turns into a solid is this first flat line, and we can see that the temperature is 12. That's where that 12 degrees comes from. Number 19 says calculate the delta H for the given reaction. So we need to know that delta H, this is an equation that you would be given. Delta H for the reaction is equal to the delta H of the products minus the delta H of the reactants. What you need to know is that the stuff at the before the arrow is actually the reactants, and the products are the compounds after. So notice I'm going to put those in my equation first. So 4NO. So we look for NO. NO equals 90, but there are 4 of them, so 4 times 90. There is another product, water, so we're going to add to that. 6 times water is negative 286. So all of that is this products part, minus reactants. So there's 4 NH3s. 4 times NH3 is negative 46. And this is, oxygen is an element. It doesn't give you a number for that. That's because it's 0, so you don't have to include that. If you put all of this into your calculator exactly the way you see, make sure you include negatives. 4 times 90 plus 6 times negative 286 minus 4 times negative 46, use your parentheses and everything exactly like you see, gives you negative 1,172, and my units are kilojoules. Number 20. Says how much heat energy. You need to know heat is Q. So we know we need to use our equation MC delta T is required to produce a 14 degree temperature change in a 250 gram sample of iron. What you were failed to be given was the specific heat capacity of iron. That's that number right there off to the side, 0.45. So Q is just going to equal all of those numbers multiplied times each other. 250 times 0.45 times 14 equals 1,575 joules. Number 20 says, what is the difference between endothermic and exothermic? These are just definitions that you need to know. Endothermic means that heat is entering the system, and exothermic means heat is exiting the system. So endothermic reactions would look like this. Notice my energy goes up from the beginning to the end, but exothermic reactions would look like this, where my energy goes down from the beginning to the end. Number 22. This big long problem is my calorimeter problem. This is where we use the equation mass of the water times the specific heat capacity of the water times the change in temperature of the water equals the mass of the metal times the specific heat capacity of the metal times the change in temperature of the metal. There's a negative here, but if you use no negatives at all, then you'll still get your right answer. So it says when an 85.7 gram of an unknown sample, that's the mass of my metal, 85.7. At 35 degrees, dissolves in 80 grams of water. In a calorimeter, the temperature of the water rises from 20.5 to 24.4. So that's my change in temperature of the water, the difference between these two numbers. So 24.4 minus 20.5. I used 3.9 here. Notice no 3.9 was given to me. I had to figure that out by subtracting. The sample has the same ending temperature as the water. So over here, the ending temperature is also 24.4. So the change in temperature is the difference between those two numbers, 10.6. The specific heat capacity of water is 4.18. what is the specific heat capacity of the metal. So one side you should have, well, the left side, the water side, you should have 3 numbers every time. You should be able to multiply those. 80 times 4.18 times 3.9 equals 1,304.16. Now I can multiply these two numbers, 85.7 times 10.6. That's 908.42x. Solve for x just like you would in math. And the specific heat capacity is equal to this number that we got right here, 1.4 joules per gram degree Celsius. Oh, sorry, I can't even see any of that. There you go. Like, one question left.
What happened?
Okay, last question. Okay, when 30.26 joules of heat, 3026, that's my Q, is lost in a sample of water, its temperature decreases from 53 to 40. That's a difference of 13 degrees. That's my change in temperature. It says, what is the mass of the water sample? So I have my equation Q equals M times C times triangle T. I can plug in what I know, which is Q. I don't know my mass. It doesn't give you the specific heat capacity, but you should know that the specific heat capacity of water is always 4.18, and the change in temperature is 13. So multiply 4.18 times 13, that gives me 54.34 M is equal to 3026. Then I solve for M just like I would X by dividing, and that's how we get this 55.7 grams. Okay, I'll put this other one back up there. This was for 22, just in case you missed that. Alright, that's the end of page